Hello everyone. Let us solve this multiple option correct type question. Question 6. In this question, we are given that a particle is projected at a velocity v at an angle theta relative to the platform, and it passes through the point P, which is at a distance of 5 meter and vertical distance of 1 meter from the point O. So we know that if this velocity is v and this angle is theta, the horizontal velocities and vertical velocity respectively will be v cos theta and v sin theta. Now it covers 5 meter with a velocity v cos theta. So the time required by it will be time equals distance upon speed. So 5 by v cos theta. In this much time it will reach at this distance. And also in this time only it reaches at vertical height of 1 meter. So using s equals ut plus half at square, s is 1 meter equals u is v sin theta, t plus half at square, but since retardation is happening, g is downward. Half a t square, 25 by v square cos square theta. 1 equals 5 tan theta minus 25g by 2v square cos square theta. This is the equation of trajectory. Now let us analyze the options. Option A says if theta is 45 degree, then v is equal to 5 root g by 2 meter per second. So let us put theta equal to 45 degree here. 1 equals 5 into tan 45 minus 25g by 2v square cos square 45. Cos 45 is 1 by root 2. So this will become 1 by 2. 25g by v square equals 4, or v square equals 25g by 4, and v is equal to 5 root g by 2 meter per second. So option A matches and is correct. Option B is that if theta is 45 degree, then the particle reaches its maximum height before it reaches P. Means such a scenario. It reaches its maximum height before it reaches P. Means P comes somewhere after the maximum height. So let us calculate its range in this scenario. Range equals u square sine 2 theta by g equals u square here v square is 25g by 4, so this is u square 25g by 4 sine 2 theta sine 90 over g, 6.25 meter. So this whole range is 6.25 meter. Since this parabolic trajectory is symmetric about this point, since this is 6.25 meter, this will be exactly half of it, that is 3.125 meter. And it is given that particle P is at a distance of 5 meter, which means that this scenario is true, that it reaches its maximum height before it reaches point P. So option B is correct. Now let's see option C. Option C is similar. It says that if theta is 30 degree, then the particle reaches its maximum height after reaching P. So this time theta is 30 degree. 1 equals 5 tan 30. Tan 30 is 1 by root 3 minus 25g by 2v square. Cos 30 is root 3 by 2. So this will be 3 by 4. So 50g by 3v square equals 5 by root 3 minus 1. That is 5 minus root 3 by root 3. So v square equals 50g by 3, 5 minus root 3 by root 3, or v square equals 50g by root 3, 5 minus root 3. Range will be u square sine 2 theta. Theta is 30 degree, so sine 2 theta, sine 60 root 3 by 2 by g. That is 25 by 5 minus root 3. This is the complete range. Half range again will be half of it, 25 by 2, 5 minus root 3. This will come out to around 3.82 meter. Means this distance is 3.82 meter and the point P is again at a distance of 5 meter. So it is again the similar scenario. So this option is incorrect. Option D, if theta is tan inverse 1 by 5, then V is 125 root g meter per second. Let us put theta equals tan inverse 1 by 5 here. 1 equals 5 times tan inverse 1 by 5. So 1 by 5 minus 25g by 2v square cos square theta. So 25g by 2v square cos square theta equals 0. Here the only variable is v, because since we know theta is tan inverse 1 by 5, we know cos theta. Only variable is v. To make this 0, v must tend to infinity, which means that there is no real value of v for which this condition is satisfied. Means for no v will this particle ever reach this point if theta is tan inverse 1 by 5. So this option is incorrect. So the correct options are A and B only.